That revolution and the evolution of fermentation-based chemicals is slowly coming in. And I think the next 10 years, you're going to again see all those lovely things there. You will say that you are eating a fermented saffron, you will be eating a fermented something. So you don't have to go back to the plant. You don't have to worry about geographical, political problems, which can be in places where some of these things are grown. So you will have a lovely time making them in small fermenters in different places. So that's where this whole area is going.
Hey everyone, welcome to the Grow Everything podcast. Karl is away. He's gone this week. He's on the West Coast. So I have a special guest here today who you might know from earlier episodes. She's also an investor at Compound VC. I want to welcome Shelby Newsad as guest host for Grow Everything today.
It's great to be here. Thanks for having me, Erum.
Woo, good. I'm glad you're here because when Karl and I were planning the podcast several weeks ago, he was going to be gone, I was going to be gone. We're like, oh no, we're going to have to pre-record this. And we don't want to pre-record, but we also just didn't want to talk to ourselves. So Karl and I met you for coffee. And after we met you, I was like, Shelby would be a great person to have on this podcast to guest host because we always talk about such fascinating things that are going on in biotech. And so here you are. And I'm very excited to talk to you because several things. We've been traveling. We haven't seen each other since that coffee meetup a month ago. You had gone to Australia. I was just in Brazil. So we've been traveling around the world. How was your trip to Australia? What was going on there? What did you see?
Yeah, Australia was amazing. I was in the western region of Australia, which is kind of a mix between Texas and California. It has the beauty and the Mediterranean climate of California with the wealth and the mining industry of Texas. So societally, it was like really interesting to experience. And also the wildlife and nature there is incredible because Australia is so removed from the rest of the world. It means the animal species and also plant species are very unique and you can't find them anywhere else in the world. I also learned that there's many different types of kangaroos. So there's the normal kangaroos that we all know about. There's tree kangaroos, which have big long tails and live in trees.
Oh, wow.
There's also wallabies, which are miniature kangaroos and super cute. There's this other animal called a quokka, which is a mix between like a kangaroo and a rat. And it doesn't sound very cute.
Does it bounce?
No, it walks like a rat on all fours. It just like walks. But it stands like a kangaroo. Anyway, it has a pouch. It's a marsupial. Yeah.
A rat that stands?
Yeah, it's very cute. And they have this like natural disposition to smile as the creature. Yeah, I'll send you pics later. Anyway. Wonderful wildlife, wonderful people. Was visiting a friend, so that was really lovely too. How was Brazil?
Brazil, similar in terms of very beautiful natural landscapes. And I saw beautiful flowers. It was a 1-week trip. I went for a wedding and the first 4 days was just downpour. So there was a rain on the parade. Like literally, we just didn't do anything. But since I went for a wedding, there was a lot of friends that were there that I hadn't seen in a while because these are friends that I have known for quite some time and we lived all around the world. And so we did get to hang out, even though we were in malls for the first few days. But after that, when it was sunny outside, it was just gorgeous. So I was in Florianopolis, which is South Brazil on the coast. And there are beautiful islands and just being in the beach. And it was such a great taste of summertime. I think this was the first trip in a while where I disconnected from work for the most part. Like I didn't schedule other meetings with biotech companies, which I tend to do when I go on family vacations, to the dismay of my husband's like, where are you going? I'm like, oh, there's this biotech company down the street in Bangalore. And he's like, what? But it was great. And I'm glad to be back. We've been busy. I came back on Sunday and then yesterday, Messaging Lab co-hosted a climate biotech event at New Lab with Cascade Biocatalyst. So Alex Rosai, who was also on this pod, and the Homeworld Collective. So Dan from Homeworld Collective was also present, representing their work, which is really building a climate biotech network. And you attended, which I didn't get to see you because I think you were hanging low key, you had a hat on, and then you just disappeared. And I'm like, wait, did I see Shelby or did I not see Shelby? I don't know. Sometimes I'm like, is that her?
Yeah, I was definitely there. And first of all, very grateful for you putting on this event with Cascade and Homeworld Collective. Thought the group of people was really interesting. I met people that are working on artificial photosynthesis, to biotech reporters at the New York Times, to people that were interested in doing detoxification of us, which is an area where I've been spending a lot of time at Compound and trying to help founders get off the ground there. So yeah, amazing event through and through. And also New Lab, such a good space to have networking events and also to have startup companies. It's beautiful in there.
Wow. I mean, glad you did some networking. You're going to let me know who this biotech reporter from the New York Times is, because that's awesome. That's great that they were in attendance. And then, yeah, I agree with you. I agree with it that there was a great turnout of people that are working on such unique things. I met people that are leveraging the GenSpace community lab. So people that don't have biotech backgrounds, but are learning, they're being self-taught, and they are being driven by the climate crisis. They know that things need to change. They see solutions in biology, so they're really trying to learn. I think you feel this, I feel this. When biologists or when people start really learning about how things are working, it gets a bit scarier because you start realizing how much you don't know, and you're like, wait, this is actually a very complex system. Biology is very, very, very complex. And that's talking about human biology and environmental biology. Things are always moving. Things are always being affected by something. There's a response happening to the actual environment, pressure, temperature, water. There's so much going on. And yes, now we have computer systems. I said computer system. I'm trying not to say AI because I'm tired of saying it. But yeah, and I know that you've also had some perspective. What are your thoughts on climate biotech? How do you define it, and what are you seeing in the space?
Yeah, that's a really good point. I think I define climate biotech as any cellular or enzymatic innovation that is being applied to climate use cases, of which there are a myriad. Anything from pollution remediation to carbon capture to new materials, I broadly define as climate biotech. And yeah, I've been seeing more in all of those spaces, in the material space, in the cellular space, but also I've been noticing a pool of talent of the AI and biotech people from drug discovery. A lot of them have become disillusioned with that industry or their ability to do impact. And like you said, it becomes existential after a while. It's like living longer only makes sense if we have a world to properly inhabit that we want to live in. Helping the climate is helping human health. And I'm really excited for the broader and broader groups of people that are getting involved in the climate biotech space.
Yeah, absolutely. And well said. That's a great definition. The disillusionment of drug discovery and big pharma, I felt that. I felt that because I was in that space, really shoehorning a small molecule to fit one disease state where people are so different that it's going to affect them differently. It just seems so lazy. Now that we know what's going on in our bodies, we're learning more about biology. We know that it can be more personalized. So how is that changing? And let's be fair to big pharma and other big companies. They've optimized their systems. They have their well-oiled machines. Innovation is hard to integrate into these big systems. But I'm glad to hear that people aren't just signing up to go into pharma because that's where the most money is. That tends to happen. But I love the fact that you're seeing that people are moving from pharma to climate and other types of companies.
Yeah, absolutely. I'm excited about it too. And if anyone's looking to make that transition as well, I feel like I have a lot of people that want to start companies on both sides and biologists that want to find ML talent to help co-found their company and vice versa. ML people that want to find biology talent to help start a company. So if anyone's listening that fits into either of those groups, always happy to speak.
Yeah, that's great. And we'll put your phone number in the show notes so people can just call you. I'm just kidding. I'm just kidding.
Yeah.
I'm kidding. So you've been talking to scientists working in unique areas. They might not know the business side of things. And sometimes I feel like that can be obvious to you or I because that's what we're looking for. I mean, I'm looking at it from the messaging lab perspective and helping people with their businesses, you're looking at it from a financial perspective. Can this science translate into a return on the investment that you're making into this company? But that's not something that they are thinking about necessarily. I don't know if you want to dig into that a little bit deeper.
I think a good rule of thumb that I love to give founders is, have they thought about the business as much as they've thought about the science?
Mm-hmm.
Because if they haven't, then they shouldn't be leading a company. They should be leading a lab, because company building has as much complexity, maybe even more, because of the human element of hiring people, of building culture, of finding the right team synergies, the projects that are manageable but could reach the right milestones that could lead to a later stage raise. So there's a myriad ways where a company goes wrong, and technology is just one part of that.
Yeah, absolutely.
Yeah. And I'm sure you know from being a founder yourself.
Yeah, I mean, that, and also just talking to so many founders and scientists. Even yesterday, when we were at this event, I was talking to, they're young scientists. I mean, they were still in school. I think they were juniors at Columbia University working on a biotech product. People are building a product. I just start asking them questions about the business side, saying like, oh, are you building a platform or a product? Are you selling to businesses or are you selling to consumers? How much money do you think you'll charge for this product? I think that was a little bit overwhelming, but they appreciated it because they're like, I actually didn't think about it like that. A lot of scientists are used to getting grants, which is free money, but investment is not free money. You have to give that money back, and tenfold. Venture capital, the other world of DeSci, is something that I actually talked about a lot recently with some of our crew, some of the people that you know. And there's two sides of the coin, saying that it's great, saying that it's not going to happen. I don't know if you have any thoughts to share really quick about the DeSci world and that as an option. And if you have, I don't know if Compound participates at all.
Yeah, we have an investment in DeSci and Molecule DAO. Initially, it was to create intellectual property non-fungible tokens to allow the funding of science itself without having to have a company that's associated with it. It's since created an ecosystem of sub-DAOs to help anything from longevity with CryoDAO to women's health with AthenaDAO to lab automation and compute with LabDAO and many others. But really, really bullish on them and the ecosystem they're building. I think there's also a lot to be done in decentralized healthcare. And that's taking the form of biohackers, patient-directed health, people taking health into their own hands, and doing anything from off-label drug use to their own blinded experiments, as epitomized by Brian Johnson. But there's a lot of other people that are taking health into their own hands. Another trend that we think's really, really impactful and I think really changes what healthcare will look like in the future.
Well said. Oh my gosh. I think we just need to have another podcast with you, but we cannot do that right now. But you bring up such great topics about healthcare and the future of healthcare. And our guest today is an OG in the synbio space, was president and CEO of Evolva for some time, which predates Ginkgo. Our guest today is Murali Muthuswamy. He knows the whole Ginkgo crew. He's been in this space for a while. He's a philanthropist. He's such a great speaker. So you guys are in for a treat. He is also the founder of Jananom, which is an organism engineering company based in India. And he's also the founder of Elive Therapeutics, which are developing living therapeutics or live biotherapeutics. He's going to talk about that. And I know you and I are going to talk about what he is talking about later after this interview. So let's hear their interview with Murali Muthuswamy. Murali Muthuswamy, we are so excited to have you on the Grow Everything podcast. Thank you so much for joining us today.
Thank you so much. It's such a pleasure. I'm joining you from India, as you know. So it's such a pleasure to meet both of you. Thank you so much.
So you're in India. You're based in Bangalore, correct?
Yes, my lab is out of Bangalore as well as another place. We are in two places in India. One is in Tamil Nadu and the other one is in Karnataka. Yes, you're quite right.
That's amazing. I was just recently in Bangalore. I met a bunch of biotech companies while I was there. It is a global biotech hub. So you're in the right place from what I see. And we actually met through an entrepreneur named Ravi Agarwal of Avisa Myco, and they are producing melanin through a unique fermentation process. I know him because of this India Biotech WhatsApp group. It's like 90 people so far. And it's really interesting because someone that was listening to our podcast reached out to me on LinkedIn and was like, is there a company doing organism engineering that's based in India that's doing something unique? And when I reached out to the WhatsApp group, Ravi reached out to me and he said, you have to talk to Murali. And I'm like, okay, let's do it. So here we are.
Yeah. He's a great guy because he did take a bit of my advice when he was doing melanin. As you know, it's not one of the easiest things to do. So there is generally, this community is pretty close, the synthetic biology community. Somebody or the other talks to you, and there are interesting challenges that come up every day. So you do get exposed to quite a lot of people. And you were mentioning Bangalore, that's the great ecosystem. I'm very glad that some of us have been associated in bringing about the ecosystem. It's been such a long time, so it's really a pleasure.
Now, you started off as an academic and you went into entrepreneurship in biotech. Can you give us broad strokes of your journey? How did you go from being an academic into entrepreneurship? It's a big leap.
I think almost 90% of the entrepreneurs would say the same thing. They would be restless. They would suddenly find themselves in a situation where they will feel that whatever they are doing, however secure their job is, however wonderful the students are, how great the university is, there is something that they will feel is missing in their lives. It has got no definition. It's an urge to do something, and you really don't know what you're doing because you set out doing an entrepreneurship with a plan A, and by the time you say that you are an entrepreneur, you would be in plan M, P, Q, or something like that. You still think that what was the restlessness that set you doing this job is the original plan. Far from it. You would be evolving over the period of time. So I have been a serial entrepreneur. The first 3, 4, I've been sort of bitten by the tech bug. I used to do a lot of digital type of work in the early part of 90s when it was very new. So people felt, what's this guy doing in the digital space? Slowly it metamorphosized into synthetic biology. Again, now you see is a beautiful confluence where digital and synthetic biology are coming together. But as a molecular biologist, I had no clue that this was going to happen in 20 years' time. So in retrospect today, I can pretend. So let's be very clear here. It would be untrue if I say I'm not pretending to say that I knew this 20 years earlier, that this would happen. And voila, it happened. But I'm sorry to say that was not how it was. I set out on something and then came here. There's a part B to that. Like all entrepreneurs, I did have my beautiful ups and absolutely ugly lows in terms of how you can run a company. So I did fail in one of the ventures. That was when the bubble burst in terms of the internet at that time. And I was running almost 10 or 15 kiosks trying to popularize broadband and trying to explain to people what are the technologies that can pass through broadband, showing live surgeries, showing live presentations and so on and so forth. And then boom, it just crashed. And then it almost brought us all to our knees. And then we had to come back again. So sorry, it was a long answer, but that's how entrepreneurs' journey is always.
Yeah, they say it's not a straight line. It's just a curve. It's like a roller coaster. You go down, up, down, back around. So thank you so much for sharing that. And you mentioned there was a moment between your digital experience versus when you entered synthetic biology. What was that metamorphosized moment? Did you meet somebody? Did you come across a company? Did you just have an epiphany? What was that?
Well, that's a good one. Actually, I was helping one of the investors here. It was a Singapore-based company that was trying to slowly invest into biotechnology in India. And let me tell you, in the early 2000s, that was not entirely too popular, meaning that there were not too many investors. One of the venture guys, he said, Murali, can you help me in trying to go through some of the proposals and tell me whether they are good enough to be funded? So I associated myself with the Singapore-based organization. In the association, I was able to meet quite a lot of my other colleagues from other venture firms. And then there was this one venture firm by the name Venture East. I don't know if you met him in Bangalore. His name is Sharat Naru. He's much more crazier than I am. I would very willingly say this even in a broadcast, and he will agree, of course. He said, there is a firm coming in from Europe. I don't know anything about the founder. So we need you to join the founding team and try to build. I told him, look, I'm not looking for a job. If you're trying to put me into such a thing, that would not be very good. He said, no, don't treat it as a job. Just be around to build a team that would be good enough to get us there. So that's how I joined the company. And the company's name is now quite well known all over. It's Evolva. And we started our journey out of India. It had several firsts in India itself, because that was the time when public-private participation was at its infancy. Another giant of a person who could visualize was Dr. Mashelkar, is a household name in India. So he was responsible for fostering a collaboration with Indian Institute of Chemical Technology, where we said we will do the biology. That is the company that I was part of the founding team. And then the chemistry would be done by them. So that is how I got into this space, quite inadvertently, without a push or a shove, just to oblige another investor. And that's how it went into the 2006, I suppose, 2005, 2006.
Yeah, and Evolva was well known. I feel like you don't hear about them as much now, but they were definitely a pioneer at the time because they were producing ingredients for food using bacteria. Can you give us some background on what they were doing just so that our audience understands that history?
Yeah, I think some of it was quite privy at that time, now not anymore. So when we as a founding team were actually associated with Evolva, so we were like any other small biotech company, very happy with some of the assets that we had. And we said that we are going to be changing the world, which is very normal for any very young biotech company to believe that they are going to change the world. Some do, of course. So backing that up was our East platform, where we felt we could make all sorts of molecules, new molecules, make a canvas of chemical structures that were very different. So we said, why don't we try to meet up with a lot of the pharma majors and the others and say, look, man, if you have a target, we can actually make a lot of small molecules for you, and then you can do a medicinal chemistry on it to make it more sustainable. The companies asked us, okay, you're trying to peddle a technology and a platform to us. Why don't you do it yourself and give us the molecules so that we could do that? That was not the objective with which we set out to form the company. But then if this was the response, then we said, might as well we adapt. But then, as you know, that this journey takes a very long time. And so we huddled together in one of the offsite meetings and said, why don't we look at certain low-hanging fruits with the technology, so that we can then chase down the bigger interest there. So that is how we decided that we would actually do molecules out of East platform. We tried to chase down some of the other things in the food and flavor industry. But I just want to add, because you may not know, as luck would have it, the first project that landed on us was a holy grail. And that was the rhabidosides of stevia. As you know, all of us were enjoying rhabidoside A and other things which came from plants. It would be very nice and sweet to taste, and then it would follow with a slightly miserable aftertaste. And so everybody was wondering, how the hell do you solve that? And the plant doesn't make it in large quantities. It makes it in very, very small quantities. So the only choice you have is to engineer it. We had one of the stalwarts in the US, Ganesh Kishore, who was with Monsanto and DuPont. He's a very well-known figure in the US. He talked to us. We were sitting on the opposite end of the table at that time. He gave us this project and said, can you do it? As always, the streak of madness and stupidity continues all through your life. So we said yes. We didn't know that he had set us up miserably into a trap where it was not to be something that has been done before. And believe me, we worked on it. And there was several beautiful things, like you have to put a sugar on sugar, you'll have to put a sugar on a chemical moiety, and so on. So it was a brilliant one that took us about 5-6 years to make it. And today, if you guys are enjoying some of rhabidosides and the others, which I possibly cannot disclose, what is that you are having today in some of your drink in the US or in any other place in the world, largely came out of the labs that we were all associated with. So that's the long and short of the story here.
That's amazing. I think a lot of us need to learn about the history of how the foods that we eat are made. And thank you for sharing that story about different types of sweetness or substitutes that we do enjoy daily. So let's fast forward because you're doing so many amazing things right now. You're a pioneer, a heavy hitter in this space. And you have two companies that you're working on. One is Jananom, and the other is Elive Biotherapeutics. And they both focus on synthetic biology, but they have different goals. So, can you elaborate on the unique objectives and projects of each company?
Sure. So let me take the easier one, Jananom. So I'm very happy to share with you that we doubled our top line this year. We just finished our accounting this year, and very happy that the team is also very proud that they have been able to double the top line. That doesn't happen so easily. So somewhere we feel that the entire idea of doing something with a service model in mind and building our own products with a revenue-led approach has paved the way for making our own products as well as helping others to build their products. So
congratulations, by the way. Congratulations. Amazing.
Thank you very much. Thank you. It's pleasing. I mean, if you can use science to get something to do this way, I think it's a really wonderful thing. And I think the whole team deserves an applause there. The part which is very interesting is that we challenged every day from clients with different type of molecules, different type of pathways, different lengths of pathways, different problems which come with it. So what makes us so unique is that people who do not find solutions in strain engineering through automation, but where you need to have a lot of customization done, then they come to us, meaning that there is a very big differentiation straight away with the companies that are very modern, very alert, and very modernized. They don't do the type of work that I do. I do more the man behind the machine type of work to build pathways. We have been doing this now for a number of clients in Europe, America, down under, and so on and so forth. Now, in addition to that, we are building very, very good pathways. We have built a fantastic set of toolkits with us. We have a lot of enzymes, transporters, glycosylation kits. Platform has been done, vectors have been done. So this is a typical synthetic biology workshop where you have all these tools there. So you can get a Jeep in and repair it, you can get a car in and repair it, and you can get a truck in and repair it. So basically the tools are very similar, except that you need to use it very intelligently there. So this is the background with which Jananom works, and we are continuing to get some good clients, interesting clients, and we have a very decent pipeline that takes us. So one of the good things that you may like to know is this is one of the very rare companies which did not go out and raise money. It was done by purely a revenue-led approach. I think even for a biotech company and for even my own enterprise, this is humbling that we didn't have to go and raise money. The freedom with which we are able to work, that's phenomenal. We have not inherited any naysayers in our setup. So it's a free for all to run their imagination. They can do anything they want. That's number one. So when we were building this, there were companies that wanted intelligent organisms, meaning that much more intelligent, like if you have to send them down a human being, will we be in a position to engineer them? If so, can we fulfill a lot of things like regulatory issues, intelligence for the bug to go and seek and deliver, ability for it to stay there, or if we are able to say, no, don't stay there. This is the end of your mission. We should be able to abort and so on. So that requires a lot of intelligence. That's where the digital space comes into being, because you use a lot of logic gate systems to build on what if scenarios for a bug to go there. So Elive is going where no man has gone before. I would say that, StarTech, I guess. So this is going to attempt a respiratory cancer. We are planning to use E. coli Nissel as one of our organisms. We very recently got our first patent there, and that's a US patent as well. So for building a pathway, which is going to be the key molecule that we want to deliver in the site of the tumor. The hope is that we will incrementally build a very intelligent bug that will be able to prevent collateral damage when you try to do a lot of drug release into the system. These bugs are supposed to go and populate intelligently close to where the drug must work and deliver it there. So this could be something that is gradually going to happen over the next 10 to 20 years. So if you see there is a similarity in what I told you in the early part of my conversation, that when I entered that space, I didn't know what would happen 20 years later. But the same thing is happening here. 20 years later, I don't know whether that's going to be right or wrong, but I believe that there will be a lot of personalization where you try to mitigate collateral damage for people, especially with cancer. So I have a feeling that with all the CAR T technologies and others coming in, there'll be a wave of new things that will emerge. And I'm hoping this is also one of them.
I think it's amazing. I want to talk about how you run two companies, but when it comes to this programmable medicine, living medicine, what are you calling that category? I know there's been a couple of other people in that category. I think maybe most famously Synlogic, who didn't do so well on their recent trial. But what do you call that category, and how do you see that category evolving over time?
Well, I call it by a very simple name. I don't know whether the Puritans will agree. It's a cell. And so you are expected to believe it's a cellular therapy because anything that involves a living cell has to be a cellular therapy. So whether you use your own cell or your own body's mechanism or you introduce something which is there. Well, the question will then come, is this a very, very advanced probiotic? In a way, it is true because probiotics are living organisms that go in and they are supposed to do something that makes you feel better, feel good. We have not gone into such great detail on what a lactic acid bacteria will do to you or what a bifidobacteria will do to you. But when it comes to engineering it and sending it down, then you need to answer a lot of questions regarding safety and all that which comes there. So I'm guessing that this will also be called a cellular medicine in a way. But I think living medicine makes it even better. But even a probiotic, in my view, is a living medicine, technically.
Yeah, this is very fascinating. I mean, we also have heard the term live biotherapeutics. I mean, there's always a lot of terms. And for us at Messaging Lab, we're always trying to find the correct terminology or the most compelling terminology to help our clients get customers. So this is one of the reasons why Carl asks. I'm also very interested in that. Hi, a quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business. So you're focusing on lung cancer. How did you come across lung cancer in particular? Why focus on that?
You have a lot of solid tumors, Erum, that doesn't really respond. There is always this very sad state where a patient would have gone through chemo, would have gone through radiation, and then there will be a refraction period where you can't bombard the patient with anything more. So you have to give him a holiday. Many times during the holiday is when the tumor sneaks back, and then there is really not too much that you can do. That's number one. Number two is the tumor microenvironment is amazing. Each tumor has a microenvironment. It creates a niche on its own. It evades the immunity, it hides, and it flourishes in spite of doing anything. So it's like all these drugs and other things go past these tumors without getting in, or you can do anything about it because these guys know how to evade that. But then if you have intelligent bugs that can go and disrupt the happy living of these tumors, they can go and bury themselves in, they can try to slowly cause problems in that microenvironment. It will give you that much of a chance for immune cells to respond. So I have a feeling one day what we are doing may not be a standalone therapy, but we will be the people like Scots going around first, trying to disrupt that area. And then slowly the immune signaling starts getting activated and the immune signaling starts behaving. And so it gives a chance for the people to do much better, meaning that there could be ways and means you can tackle cancer. So there's going to be a whole lot of approaches. And in these approaches, each one has its own little merits that's going to come. We all have to cooperate and see how we can put a system in place so that the patient ultimately gets in. I doubt very much that each one of these systems can do on their own. They may need to collaboratively work together to do it. So that's how we landed here. And believe me, I started this much before COVID. I had no idea what was going to happen into the respiratory system and so on. But I started much earlier than COVID because we built something for another client. And we said, okay, yeah, we are getting intelligent. Why don't we build something for ourselves? So that's how it started.
Yeah, the approach is fascinating because there are so many different kinds of cancers. And like you say, the cancer tumor cell developed its own microenvironment. So every one of those cancers potentially needs its own kind of therapy. And then every person is different, which means you also have to personalize for what that person is
Correct.
like. So I don't doubt that this is the future of where we're going when it comes really to all serious disease.
Yeah, that's true. It's a question of how do venture people have the appetite for such technologies. I mean, while I believe that a lot of us, when we sit on the other side of the table, always say that we are bold, but when it comes to handling somebody else's money, your boldness can only go up to a point. So one of the things I did here also, Erum, is I didn't take money from anybody. I said, okay, let's do it and see what happens. So you go with it to a point where you are saying, yeah, I'm going to build it. So today I've come to a stage where I have to do the preclinical. I'm in a preclinical company there, so I have to do the animal study. There are very, very few places in the US where you can do these type of animal studies where you need to have a very sterile animal and all that. So there are only about that many there. So hopefully one of these days I'm going to hit the road to raise money to get this going in one of the places in the US. I mean, I'm thinking US because a lot of my background comes from that country, from 1985, 86. I'm comfortable doing work out of some of those labs.
Yeah, congratulations for not raising money. That's a huge thing. I had talked to a founder recently and they hadn't raised any money and they're making R&D products and they just bankrolled it themselves, but they saw it as a negative thing because they're like, oh yeah, we haven't raised money. I mean, they had revenue. And I was like, what are you talking about? This is amazing that you guys haven't raised money and you're realizing revenue already. And he's like, really? It's like, no one's ever told us that. And I was like, am I taking crazy pills here? Like, this is a magical thing.
Right.
So congratulations. And I love the term, the micro environment, because it alludes to complexity. It talks about the complexity of tumors. And I think I would love for us to visualize what exactly the bug you're engineering is doing without obviously revealing too much. But is it suppressing the cancer cells? Is it going the tumor and self-exploding and killing it? What is the actual thing that it's doing to therapize the tumor?
Supposed to do is very simple, Erum. You know, these microenvironments, they have a very hypoxic core, meaning that they keep away oxygen, even though they burn out the maximum amount of sugar. So if you remember, there were times when cancer patients were supposed to eat well because they lose a lot of weight and so on. And then there was this question, should they be having a lot of food because you're supplying the much needed sugar for the cancers to proliferate? So should they be starving? So there's juries out there. But the point is, this microenvironment is a very specialized place, like a black hole on its own, if you want a parallel to that. They have a mind of their own and they metabolize and do things on their own and proliferate and so on and so forth. So all this microorganism does, if you look at the whole animal like you and I are, what happens is when you get a cold, when you get a bacterial infection, when you get a urinary tract infection, what happens? They disrupt a big biological creature like us. This bug that we are engineering is just going to do a very similar thing in the microenvironment. It's just going to go and disrupt it. So it will seek the hypoxic core, go there, and if there is a payload that we have put it on it, it will be intelligently delivering it depending on the signals that has been built in. So it's more, let's say, a complex engineering, a synthetic biology at its best. And I'm sure with a lot of tools and a lot of new things that are coming out, this area will get even better than what I am doing. Maybe I'm doing, let's say, the analog version of the bug creation. So when it gets into the digital world, it should be doing much better than that. So I want to leave this legacy to the younger generation to pursue this and attack a number of other problems, different problems, so that they can actually take it to a different level altogether. So that's the whole idea.
What I would mention, you said that these tumors tend to be hypoxic environments. And just to remind our readers, one of the things that happens when you have a tumor is the cancer sets itself up to receive nutrition, as you said, Murali. So it vascularizes, meaning it creates a network of capillaries into the tumor so that the tumor is being fed. What I think of when I think about your medicine, these kinds of living medicines, and what it reminds me of too, is that cells respond to their environment. Naturally, cells move around, they're looking for food. If there's sunlight, they'll retract. If it's a toxic environment, they'll move away. And so when I think of these kinds of living medicines, you program a series of steps in them, almost like a computer program. I think that's the closest analogy. For example, they get into this environment where it's very nutritious, but maybe, as you said, it's a black hole. That triggers a bunch of behaviors, and those behaviors are set up to really attack the tumor without it realizing what's going on. I think of it as being very, very complex and very intelligent, and also fascinating from a therapeutics point of view. So congratulations.
But you summarized it very well. Actually, the complexity is enormous. Even if a Puritan is going to listen to this podcast, he might come to the conclusion Murali is trying to make it very simplistic. But my intention is not to trivialize the complexity, but to make it more understandable. But you are absolutely right. This type of work that we are trying to do will have to be done holding hands with major companies, major thought leaders. We will all have to push in one direction to make some of these things happen. So this is very different from the usual drug development that people do. This is another very fascinating area. So there are several ways in which you can make a person live longer. So this is one of the other ways of doing it. We're going to have a situation where some of these bacterial resistances that are being built because of the antibiotic resistance, as you know, there could be ways in which you could send a bug down there to compete and also try to be intelligent enough to dispel the other villain sitting there. If you remember, long back, there used to be a bug called Pseudomonas syringae. And what it used to do is it used to go during winter times and hit the plant part where it will cause it to lose its ability to retain water, retain a lot of things. It used to form these little nodules there, and then it used to fall off. So one of the ways in which it was tackled was to send something which was avirulent and send it. So it's almost like the vaccine principle, the avirulent part there. So the basic fundamental thinking is very similar. The approaches for doing these things vary, be it plants, be it human beings, etc. Whether it's antibiotic resistance or if you're going to throw a bad bug and put a good bug, all that is the basic underlying philosophy is the same. It's the technology that is making it beautiful so that you can almost try different types of approaches on the basic fundamentals there.
I'm curious, I was just about to ask about the different applications. So you mentioned the antibiotic resistance, especially in plant diseases, which is important for us when it comes to food and other things that plants provide us. But in terms of human health, you mentioned cancer. Any other diseases that came to mind immediately when you first were thinking about this? You're like, okay, there's cancers, but there are these other diseases where, we're calling it living biotherapeutics. What other diseases have come to mind where like, this is going to be great and you want to let younger generations know to perhaps look into it?
Actually, there's quite a number of them. Synlogic pursued something very similar where you don't have one enzyme, which is very important for conversion of a substrate to a product, that the accumulation causes toxicity. So there are several of those where genetically somebody is predisposed. He doesn't make those enzymes. He doesn't make that one step in his body so that he's not able to move. So there are several of these low-hanging fruits, actually. You can actually chase quite a lot of them. We decided lungs because we knew there won't be anybody there. We'll be the only guys doing that. But there are lots of other GI, as we call it, the gastrointestinal area, where there are quite a lot of it. I mean, you can look at certain type of pancreatic cancers, you can look at certain type of liver cancers, and so on and so forth. But these things will need a lot of effort, a lot of investment, a lot of foresight, a lot of trust, policies, everything to back up. So when you're new, it's always nice. You sound great on a television show or on a podcast, but you have to remember you're going alone there and you don't know what's on the other side. You will have to be pretty good. So it's good to make these podcasts to appeal for people to join. You know what I mean? More people coming in, the better it is.
Yeah, I mean, that is the purpose. It's like we want more people to understand what these technologies are enabling. And to be honest, we don't talk that much about the healthcare side, even though that's always been a really important part of our business. If it's okay, I'd love to switch gears and talk about Jananom. Talk a little bit about how does that company leverage synthetic biology and what are the products and how do they improve health?
Oh, that's something that's very obvious because there are a lot of resistance to chemical ways of making small molecules, specialty chemicals, etc. There are a lot of intermediates that could be quite toxic, which you don't want in your environment. There are lovely small molecules that require photobiology there. Photobiology is not so easy because in chemistry, that's one of the hazardous steps that could happen. So you don't want certain molecules to be made that way. So which means then you're coming back to a very sustainable way to produce. And synthetic biology used to have just glucose as one of its substrates, and then it could have the 5 and 6 sugar components. But today you can use gases, you can use a lot of complex carbohydrates. So there's on the other end of the spectrum, the feed for making these organisms is now going through a big revolution. There's so many small biotech companies which are doing that. So their research will pave the way for newer substrates to come. And if we engineer organisms to make these specialty chemicals, then you can make them in a very sustained way without having to lead too much into chemistry. So there will be a time, I would always say the previous generation, the previous era was for chemistry. So I am of the firm belief that the next generation, next era will be led by biology. And largely because there is so much of assistance that has come from the digital world. To answer your question, Jananom chases down molecules that are hard to chase in terms of chemistry, number one, or the natural extraction process does not allow you to do that because you would be taking out quite a lot of those from environments that are not very good to do because you don't like to do that. So it's better to synthesize the genes that would possibly be there if you had taken from a plant, doing it in a lab and then putting them inside. That makes a lot of sense too. So most of the specialty chemicals that you're going to be using in food, which has got nutraceutical applications, which has got pharma applications, are likely to come here. But why did this not happen faster? Why is it that still we are talking about this and we don't see 150 synthetic biology companies making 150 molecules? So one of the biggest problem has been in the previous generation is we have tried to fast track from the lab to a commercial system because nobody had any clue how long it's going to take and how much of effort is going to be needed to get it to the next stage, number one. Number two is that there's a lot of in-process, let's say, facilities now that are available because there are brilliant probes, brilliant ways in which you can actually see what's happening. It's like the beating heart surgery. You don't have to really stop the heart from beating. You can still do the surgery. So it was such a big discovery in those days that you don't have to do anything to the heart. You can still do a surgery. Very similar to that now, there is a possibility that we don't have to rush to the commercial scale. We need to put up a very good integrated facility where you will be able to do the gene, the synthetic biology part of assembling the genes, doing the bioengineering of it. You can do the process development, which is from 1 liter to, let's say, about 5 kL. You can do the analytics alongside it. You can do the purification alongside it for regulatory, customer sample, etc. So if you have these little factories, if you may call it, where it is integrated with the strain engineering and not have a very dissociated one. See, most of the planes, as you know, door is made somewhere, the windows are made somewhere, the engine is made somewhere, and then assemble everything together. Now, that somehow in engineering world, it has happened and it's been pretty good. And hopefully that's one of the reasons we are safely flying. But in biology, you need to stay very close to the living organism because you can't treat a living organism like that, where you can put them in different places and assemble together. So the fast tracking of the fermentation industry did not happen where it was cost effective because you could still make, but it was not cost effective. And chemistry always said, hey guys, come on, tighten your belt. You can't beat us. And there are countries which you don't have to name, you know very well, who are strong in chemistry and they can bring the prices down and hammer you down. Now there is this wave where technology is again helping, where you can put these integrated facilities, understand the organism better, then toss it into a bigger fermenter so that, you can start doing. So that revolution and the evolution of fermentation-based chemicals is slowly coming in. And I think the next 10 years, you're going to again see all those lovely things there. You will say that you are eating a fermented, let's say saffron, you will be eating a fermented something. So you don't have to go back to the plant. You don't have to worry about geographical, political problems, which can be in places where some of these things are grown. So you will have a lovely time making them in small fermenters in different places. So that's where this whole area is going.
Yeah. Yeah, I can tell Carl's thinking about this because we talk a lot about biomanufacturing, we actually had a gentleman, Edward Shenderovich of Synonym, and his whole company is biomanufacturing on the cloud. And he has a whole map of biomanufacturing facilities around the world, gets all of this information about each of those facilities, what type of instrumentation do they have, what type of resources do they have around them, to really help people that are looking to biomanufacture something, like to find an existing facility. But then he's also going to use that data to standardize the creation of biomanufacturing facilities to have some standardized parts, although we know that there's going to be customization depending on what type of company will need to leverage those manufacturing facilities. And I'm actually really curious because when I had gone to India in December, Carl asked me the question. He was like, what's going on in biomanufacturing in India? And I didn't really look into it because I was meeting more of the startups that were really working on the smaller scale. But of course, they need to then scale up. And like you're saying, being very close, they need to have their little baby organisms scale up to this mass culture, but need to be close to it. So I'm curious, my question really is, what type of manufacturing setup do you have, and what is happening in India in terms of biomanufacturing? Where are the advantages and disadvantages?
Easiest to answer is what the government of India is doing. Some of us are associated with the various committees that the government is forming. The current secretary of the Department of Biotechnology, Dr. Rajesh Gokhale, is really dedicating his entire efforts to biomanufacturing. He believes that the future is biology led. So there are several initiatives that are going to happen in 2024 and 2025, where there's going to be all these conventional proteins that are going to be made through fermentation and through what we call as smart protein, plant-based proteins, then the animal cells that are grown in labs, and so on and so forth. My effort is on small molecules because I know there aren't very many people in the world who follow from the strain engineering to the end. So I wanted to stick to my core expertise here. That is one of the reasons that I am planning to raise money this year. After a very, very long time, almost nearly a decade later, I'm raising some money for the simple reason that we need to put up this integrated facility and you have to walk the talk. You have to say, so this is what the integrated facility will do. Guys, do this across, and then you will be getting a cost-effective solution when you try to go for commercialization of any complex molecule. So India has followed everything to the last letter in terms of planning. There is now going to be money that's going to be disbursed by government doing this. And I think the next 2 years, you both are going to hear quite a lot of new companies coming out in the biomanufacturing space here. That's largely because, as I was mentioning in the beginning of this podcast, is that unless there is going to be a trust given by a lot of people, including government and the agencies, you need lots of people to come together. So that's how India is now looking at the biomanufacturing policy. So there is a policy out there now.
That's so exciting. I'm really looking forward to hearing what that progress looks like. So you live in Bangalore. You're part of this ecosystem. Bangalore is like this global hub for technology and now for biotech. And you have a lot of experience working with younger entrepreneurs. What advice do you give to these entrepreneurs that are going to be coming on board in biotech? What gets you excited that you want them to know?
Hey, first of all, they don't like advice. So I'm very happy that I don't have to give one.
Love that. I love that. That's so true.
Yeah, they are very smart. I have to tell you that. So one of the things is that they are bold. I mean, they are not worried about taking risks these days. I can see that they don't mind starting all over again. They are not worried about the stigma of a failed entrepreneur, number one. Number two is that they are very much glued. A lot of the new generation entrepreneurs who are coming in are spending quite a lot of time trying to understand technology and trying to use technology in different ways. A lot of them stun you when you try to give a lecture or you try to do a seminar. The type of questions that come to you is you would be saying, oh my God, why was I so dumb? I didn't even think about this idea. So that's the level at which they go. But one thing as experienced entrepreneurs can say, if you don't construe this as an advice, is that this is a long haul because of the simple reason that when you start and when you finish, you will not know that you have spent at least a decade for something to have come out, except for these very, very, very low-hanging fruits that are around there. A lot of what you solve, which are critical in somebody's life, is a 10-year journey or a 12-year journey before something happens. So you have to stay very grounded and very focused. So in 12 years' time, you're going to have so many ups and so many downs. You have to be able to take it along with your journey and not quit or change course. Or just because we all say that we started with plan A and went up to plan P, it doesn't mean that you have to do that. That's not what I'm saying. You will have to still be within that to make all those changes before you achieve your end objective. So I think that's where patience is a very important thing. That's where I think the younger generation used to lightning speeds in their internet, 5G, 6G, maybe 10G at some point of time. For them, anything has to happen now. And that may or may not happen in biology. You will have to have that sort of resilience and patience. I'm only stating a fact, and let me say bold italics and underline, youngsters, I'm not giving you any advice.
Biology works on its own time scale. That's the thing. It's not the digital time scale.
Yeah, that's really great. Yeah, thanks for sharing your perspective. You did not share any advice. Thank you so much. It's so funny that because we talk to a lot of entrepreneurs and they always ask for advice, or someone reached out to me about being a mentor. I'm like, I'm not a mentor. I can talk to you about things, but you are doing something far more complex. I want you to mentor me about the type of technology you're building. And a big thing too is your go to market. A lot of times I see entrepreneurs that are just so into their technology. I'm always curious, who are your customers? How are you going to market? Because if this is a for-profit company, especially if it's venture-backed, that's where you have to kind of focus on how you're going to get that return and how you're going to make that money. So that's always a big question that I like to ask. So thank you so much for sharing.
After this interview, I have to meet my daughter, right? So if I'm going to be a boring dad giving advice, she's not going to like it. So I better be careful.
Oh yeah, the kids, I mean, they'll never listen to advice. They're like the first people to be like rolling their eyes at you. Any companies out there, I know your company is awesome, but any companies out there that you think that should be on our radar, things that you think that are very exciting? I know there are a lot. You can't pick one, but off the top of your head, so just ask the question, any biotech companies that you're excited about?
We have quite a number of companies, actually. I could do another podcast with you on that because there are so many nice companies there. But I think you may like to stay focused on a few that are into CAR-T technology here. They're really meeting some good success because I think the most deserving population that needs some respite is the cancer patients. I think we have been researching and coming up with all sorts of new things, but you still end up getting people succumbing to the disease. So I think CAR-T is giving them that breathing space. There is something that's happening, which is exciting. And companies that are promoted by the Biocon group and the Tata's group and so on and so forth, they are doing some good work there. And I think the cell and gene therapy companies are also doing pretty good. I mean, some of them are coming up with lovely things like you could possibly not have a damaged tooth anymore. They could probably restore it. There could be other areas that they can actually work on to restore. I think that those are some of the companies that are very interesting. And believe me, the other companies that are doing wonderful work is these non-invasive ways in which you can actually talk about people and their likelihood of a disease or prediction, where you can validate some of the things that they do, scanning the eye or using some devices to talk through your texture or the electrical conductance of your skin and so on and so forth, or saliva or urine or feces, where you really don't have to put a patient to a prick, an injection. Those type of technologies are coming up pretty rampantly. And I have a feeling that your watch, your personal device, whatever you may call it, is going to be super intelligent in a few years. And that's the confluence of biology and digital world that's happening. And India is having quite a number of startups in that area. So they are tackling all sorts of things there. If it combined with genomics, if you are able to validate, of course, and predict how things are going to happen, how things will happen, what are you supposed to be taking care of, how can you live longer, shorter, whatever that is, I think it's going to make a hell a lot of difference to the way you live. But one thing I have to say is all of us would have had our little binges when we were in colleges or college or in places we could eat or drink or make merry. Now your watch will tell you, sorry, you can't do all those things. So I don't know whether it's taking the life out of you, the fun out of you, or it's making you live safer and longer, like seat belts and all these devices which protect your car. So it's a bit of both. So I don't know which side it is. From this side, you could talk about it. From the other side also, you can talk about it.
Yeah, that's so well said. I just feel like I have so many more discussion points to speak with you, so we'll have to have you back on because the intersection between digital and biology is something we do need and will and have been talking about on the pod. But in terms of use cases and things that are happening now versus a year from now, I don't even want to say like sometimes it's like, oh, what do you think is going to happen in 5, 10, 30 years? No, what do you think is going to happen tomorrow? Because of the pace at what some of these digital products are being built is changing so quickly. So,
Yeah, you're right. You're right. You're going to have a lot of these intelligent devices around you. And I can tell you that you're going to see it in your lifetime. It's not too far away. The bigger manufacturers are going to incorporate them into their various devices. And as you know, these devices anyway are getting smaller and smaller and smaller due to processing speeds and the ability to put a lot of things in it. If DNA is going to be also a methodology for storing a lot of things, it's going to be even more interesting on how we are going to keep all this information there. So we are in for an exciting journey. Let me tell you one, all commercial people and all these technology mavericks, I can tell you we are all super excited all the time. Our adrenaline keeps pumping. We are restless. We are like kids with a syndrome where you don't know what you're supposed to be doing, always jumping up and about. Sorry, you have spoken to another such crazy fellow here. I can't bring in anything which is sober here. It's all pulsating and exciting all the time. And so that keeps a whole new generation coming up with brilliant ideas. This is the time. We are living at the best possible time in the world, tackling hundreds and hundreds of different things with a huge younger population who will do anything that you do twice as fast or 4 times as fast as you do. These are great times, I have to say.
Well, thank you so much, Murali. I think a wonderful note to leave this interview on. We definitely want to have you come back. Thank you so much.
Thank you very much for having me on your show. And I think both of you have been splendid. I hope I have not bugged your audience, but I'm hoping that there will be something that they feel excited at the end of this podcast where they feel, oh, yeah, here is a guy who's a maverick and there must be hundreds out there. And you guys will go and seek them and put them on your podcast in future.
Thank you.
Yes, absolutely. Absolutely. It's been an absolute joy, Murali. We will be in touch for sure.
Thank you so much.
Wow, what an episode. Chock full of inspiration, entrepreneurial insights, tech predictions. I felt like it was very motivating. Just so amazing, all the work he's doing. And I'm so excited to hear your thoughts, Shelby. What did you think of the episode?
Yeah, fantastic episode. I'm inspired by his dedication to both the ecosystem, to entrepreneurship, to finding new use cases, and also supporting young entrepreneurs that are continuing to carry the torch as well. So great episode.
Yeah, I love the fact when Carl asked him giving advice for young biotech entrepreneurs, he was like, I don't give advice. No way. No, 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 no. I can share a perspective. I can share some thoughts, but I don't give advice because the younger generation, they're very, very smart. They're fast. They're nimble. So he acknowledged that. But he also made a point that today's generation we do move too fast. I mean, younger than me, just move very fast, but biology may not move as fast. So he also kind of shared a little bit of insight that some patience is required when it comes to biotechnology. It's not the same as developing an app or something that, boom, you're live in a night. So I think that's very powerful.
Definitely. And I thought it was interesting, his experience from Jananom, which does SynBio services and partnerships, and Elive Bio, which does live biotherapeutics. But from both of those, even though they're working on downstream products, a lot of the core technologies and the timescales are similar. And obviously, expertise of Murali can be used across both of those areas, which I think has a lot of potential for the climate biotech movement that we were talking about at the beginning of this episode.
Oh, yeah, absolutely. Absolutely. Biology is everywhere. It can be a solution, whether it's for our health. We really focused on cancer therapeutics, which I do want to talk more about with you. I know you've seen a lot in space, but biology is also an environment, and there could be similar frameworks to be used, whether it's our health, human health, animal health, or resolving some of the climate situations. I wanted to talk a little bit more about when Murali was talking about the tumor microenvironments. What are your thoughts on that? What have you seen? Have you seen other companies in the space? What have you learned about the space? I know you're just chock full of knowledge, Shelby.
Yeah, tumor microenvironments. I've seen a lot there. Anything from there being different pHs in tumor microenvironments, in terms of there being a stroma, which is like a protective layer around these environments that help with the evasion of the immune system, which is a problem, and why a lot of people posit that the cell therapies that have been so successful with blood cancer haven't been able to translate to solid tumors. Something else that I've heard about in terms of the tumor microenvironments is just how dense some solid tumors are. So apparently, if you extract a pancreatic cancer tumor, it's as hard as a golf ball.
Oh my God.
Yeah.
That's just cells? Like, what is it?
It's cancer, but it's very, very hard. So I think there's other complexities in terms of being able to permeate that rigid of a structure that also physically makes medicines difficult, and why more innovation and smaller cells like Elive is doing could be potentially useful, because mammalian cells versus bacterial cells have just such a size differential, but being able to really get inside, first of all, like through the stroma and then get inside the tumor could be a really interesting advantage for Elive.
I love the way that you're painting this picture. The solid tumor getting inside the different sizes of the mammalian cells versus the bacterial cells. How do they get into the fort and kill the cancer, right? I'm really curious to know, what are in these microenvironments? Are they all just living cells, or are there other molecules that are being deposited? There's some kind of calcium being created. Do you know of what's going on in these microenvironments besides the cancer cells?
Not really. I know that the metabolism shifts from being oxidative phosphorylation, which is like a really efficient energy process, and glycolysis to just being glycolysis.
There's actually a few companies that you have seen working in the biologic space. There was something that you said to me about a biologic that delivers a precise payload to a tumor site. What was that term that you used?
Yeah, so there's this company called Senti Bio that I think has somewhat of a similar premise, but it uses gene circuit engineering to deliver payloads at the right environments. I think this is the upshot of where all of this technology is going, to where you have living therapies, you can regulate the expression of the therapy through inducible promoters. Because of that, you can have really specific delivery of medicines to the site, which is experiencing the cancer or the infection. That could be through logic gating or smart sensors or aptamer-based approaches. There's a myriad of different approaches, but it's something I think will become more and more common as cell therapies become more common, because cell therapies become more efficacious if we're able to tune their therapeutic potential. Like we can tune therapeutic windows for small molecules or biologics. Another thing I've seen is in diseases where people are deficient of a certain cell type, there are companies that are aiming to re-implant that cell type. So in type 1 diabetes, your immune system kills your pancreatic islet cells, which make insulin. And there's a company called Insulin. It's not a portfolio company, sadly, but this company re-implants pancreatic cells into someone. So that way they don't have to dose themselves with insulin, because the cells automatically sense the requirement for insulin and are able to give that to someone's body. They're just pancreas cells that are in a little encasing that protect them from your immune system. So your immune system isn't able to destroy them like they did with your normal cells. So because of that, they can function properly without being destroyed by your immune cells. And functioning properly means sensing the sugar load in your system and then dosing the right amounts of insulin from that, which is kind of amazing. So I think it's great that cells can be used as an attacker of bad cells. We can use cells to attack cells that shouldn't be there in the first place. And then we can use cells to replace cells that should be there in the first place.
I mean, I love that. That's so fascinating. That would be huge for this company. And diabetes is a very pervasive disease all across the world, especially people consuming Western diets that are high in sugar and fats. How far along is the company? Do you know?
I think they just raised a Series A last year from Coast Lab Ventures, I believe. And so they'll be entering the clinic soon-ish.
Nice. Yeah, I'll be keeping an eye on them. That's great. I have family members that unfortunately have diabetes and they're taking insulin shots, and it is what it is. But if there's something that could be better for them, that's great. I mean, I would love it. So, Shelby, you're a wealth of knowledge. Everyone knows that. Everyone in this industry loves speaking with you. And you are working with one of the biggest organizations in Synbio Beta. You'll be there. You're running a track. Can you tell us a little bit more about what's going on with you at Synbio Beta this year?
Yeah, I'm super, super honored to be running the AI and digital bio track at Synbio Beta. We have some really amazing sessions planned for people. The sessions range from generative protein design to foundation models in biology to different funding models for biotech as well. And the speakers include people from Arcadia Science, people from Future House, OpenAI. This science person from OpenAI will be speaking. On the protein side, people from Lab Genius. There's also going to be a panel on AI optimizations for synthetic biology as well. So I'm really excited to talk about all the different AI applications in synthetic biology and in traditional biotech.
Ooh, wow. I'm excited to learn about what's working, what's going to work soon, and what's not working. I just feel like when it comes to a lot of technology and the hype, and I love it. I love innovation. I love people thinking of the best possible way of doing things. But are we looking at the worst things that could happen? And who are the leaders so we can see what they're doing, improve upon what they're doing, and learn and see and make sure we're making the right moves rather than everyone's running in parallel. We're all making the same mistakes. I'm thinking about the social media space. That was just kind of a free-for-all. Biology is a little bit more intimate. I'm excited to learn. I will definitely be at your track. I will listen to your talks. I will be there supporting you, learning from the guy from OpenAI. I'm very excited to meet. What's his name?
Boris Power.
Oh, Boris Power. What a name. Awesome. So if anybody wants to join us at Synbio Beta, please come. You're more than welcome to. We do have a discount code. So the promo code is Grow Everything. So when you register, you'll get $300 off. And we would be very happy to see you. And we can continue the conversation live there at Synbio Beta. Man, John Cumbers, lucky to have you. Lucky to have us to really do this promotion. We love it. We just love it because it's a great organization. It's a great meeting, great conference. You have access to some of the most brilliant minds working on some of the toughest challenges. So that's a wrap. Shelby, is there anything else you wanted to share with our crew? We have other things coming up. What's in store?
Yeah, just super excited for Synbio Beta and just excited for more New York climate biotech events and to see a lot of friends and colleagues at Synbio Beta.
Yes, absolutely. And then I hope to see you soon again. We'll have to grab some coffee. We'll go to Devotion again, even though you have lots of fans out there. Last time we grabbed coffee, Shelby was stopped by people like, oh, Shelby. So hopefully we'll have to go somewhere more discreet.
Yeah, I can't go to Devotions in New York without seeing people I know. It's the VC hub of New York.
Yeah.
Anyway, thanks for having me. Big fan of the podcast and really amazing hearing the talk with Murali earlier as well.
Awesome. Well, we'll have to have you back on, of course. You're a friend of the pod. Thank you so much for making this more interesting and sharing your knowledge. So I will certainly be talking to you soon. Thanks, Shelby.
Sounds good. Thanks, Erum.